Okay, I want you to go ahead and try the warm-up. Just make sure that you start by marking up your diagram. So we know that AM is congruent to AN and that AT is a median. So a median goes from a vertex to the midpoint of the opposite side. So those two segments would be congruent. So if I'm trying to prove angle M congruent to angle N, if I can get these two triangles congruent, then I would be able to use CPCTC to say that they're congruent. So we'll go ahead, we'll write the given. And then we'll say in step 2 that MT is congruent to TN by the reason we said was if median, then divides into two congruent segments. And then in step 3, we can say that segment AT is congruent to segment AT by reflexive. So we have side, 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 and we can say that triangle ATM is congruent to triangle ATN by side, side, side. And then we can see that angle M is congruent to angle N by CPCTC. So you can see that we started off with an isosceles triangle, and what we ended up proving was that the base angles of this triangle were congruent. And that's our first angle side theorem, which says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. And you can write this symbolically in your proofs by writing if and then draw a triangle with two sides marked congruent. Then you draw a triangle with the base angles marked congruent. Now the converse is also true, and you can say that if two angles of a triangle are congruent, so you can draw a triangle with the base angles marked congruent, then the sides opposite those angles are congruent. So then you would draw the sides opposite the two angles you had marked earlier congruent. So in your proofs, you can use these for the reasons. All right, so let's try using that theorem. All right, so first I know for part A that SO is congruent to SH. And I want to know which angles are congruent as a result of those. So the angles, the sides rather, are marked on this isosceles triangle that I'm highlighting in yellow. Okay. So the base angles that go with these sides on the triangle that's highlighted are angle O and angle H. Okay. In part B, we know that angle SUH is congruent to angle STO. So these base angles belong to the triangle that I highlighted in orange. So what that means is that segment SU is congruent to segment ST. Okay. It would not be okay to say that SO is congruent to SH for part B, because they are not part of the triangle that angle SUT and angle STU are base angles for. All right, so the isosceles triangle definition and theorems. we know that if two sides of a triangle are congruent, then the triangle is isosceles. That's the definition. And so you can just mark that as if two sides are congruent, then it's isosceles. That'll be the abbreviation we'll use. Additionally, we can say that if two angles of a triangle are congruent, then the triangle is isosceles. Symbolically, that can be written: if base angles are congruent, then isosceles. Okay. Third, if a triangle is isosceles, then two sides of the triangle are congruent, which we can write as, if isosceles, then two sides are congruent. And finally, if a triangle is isosceles, then the base angles of the triangle are congruent, which we can write as, if isosceles, then draw a triangle with the base angles marked congruent. So example 2 says triangle WTZ is isosceles with base WZ. So what that means is if this is the base, then TW and TZ are the legs, and those are what we can mark congruent. We also know angle 3 is congruent to angle 4, and that segment TB is congruent to segment TA. And we're trying to get that these two, that segment BX and segment AY are congruent. So if we can get these two triangles at the bottom here congruent, then we can go ahead and say that BX and AY are congruent by CPCTC. Now, right now we have one angle in these two triangles. I can get BW congruent to AZ if I use subtraction. And we can use subtraction because we know that if we take TW minus TB, that equals BW. And if we take TZ minus TA, that equals AZ. TW and TZ, oh, I didn't say those were congruent yet.